Hello everyone. Today we'll discuss about measurement of length. Length is one of the seven fundamental quantities that we have discussed last time. And to measure length or distance, we have seen the SI unit is meter. So in 1960, a standard for meter based on the wavelength of orange red light emitted by atom of krypton was adopted. Krypton is one of the noble elements like helium and neon. By 1983, a more precise measurement was developed, and it said that a meter is the length of path traveled by light in vacuum during a time interval of 1 by 299792458 second. So, in that fraction of second, whatever is the distance light travels is nothing but 1 meter. Okay, and from that only this was possible as by that time the speed of light in vacuum was measured precisely as 3 c is equal to 299792458. We normally write it as in a round figure 3 into 10 raised to 8 meter per second, but to be precise this is the value. So this is how measurement of length ka standard, which is 1 meter, is defined. So just to revise, this is the definition that is used. So in the fraction of 1 by 299792458 second, the distance that light travels is nothing but 1 meter. Okay, so let us go ahead. These are few standard distances. Uh, Distance to Andromeda galaxy. This is the nearest Milky Way to our nearest galaxy to our Milky Way. Nearest star after Sun is Proxima Centauri, which is at a distance of 4 into 10 raised to 16 meter. Distance to Pluto from Earth is 6 into 10 raised to 12. Radius of Earth, Everest. Thickness of this paper means the paper of the textbook is 10 raised to minus 4, which is 0.1 mm. Right? This is nothing but 0.1 millimeter. Length of a typical virus is 10 raised to minus 8 meter. Radius of a hydrogen atom is 5 into 10 raised to minus 11 meter, and radius of proton is 10 raised to minus 15 meter. So you can see the variation from 10 raised to 22 to 10 raised to minus 15. That is the large scale of measurement that is being done. So how to measure this large distances? First we'll talk about that. The method is called as parallax method. So in parallax method, what we do is, even you all can try this. If you are seeing this on mobile phone or laptop or desktop, what you do is see the presentation from your left eye by closing the right eye, and then you switch it. Means for the next time you can switch it and see the presentation or the mobile in front of you from the right eye and close the left eye. You will it will appear that the object that you are holding, in our case the mobile, has shifted, वो थोड़ा सा move हो गया. Okay, and this is nothing but called as parallax method. uh, so parallax is defined as the apparent change in the position of object due to change in the position of the observer. So previously we were observing with left eye and then we saw with right eye. So there is a change in the position, and that uh, leads us to what do you say, feel that the object has moved actually, but that is not the case. So let us go ahead. This is an example. So the object that you are seeing, the position of that object is fixed. Okay, now let us say we observe the object from left eye, and so this was the line of sight. This was the line of sight. Now when you moved switched the eye, let us say now you are observing it with the right eye. In that case you will find this is the line of sight. Okay, and just because the background has changed, we feel like that object has shifted. This object has shifted. So when we are seeing from here, we feel like it is on this side. When we see it from this eye, we feel that object has shifted on this side. So you can try this on your own. And there is some angle theta which is formed between these two lines, and we know what is the distance between our eye. Okay, so let us say this distance is nothing but small d, and this length is nothing but capital D. Okay, so if you use the formula S is equal to r theta from circles, so over here we know this S is nothing but d over here, r is nothing but capital D, and theta. So to calculate the distance, what we do is we use this formula d by theta. So if you know the distance between E1 and E2, which you will know because that is the distance between the eye and the angle that is being formed. Okay, so that will give you the distance from here to here. Okay, so I hope you have understood this. Let us go ahead and see one more example. So what we have is we have so we are on earth, and let us say we want to measure the distance to the sun. Okay, now the distance between our eyes is very less to measure this kind of distance. So what we will be doing is we will be going to one end of earth, and wahan se we will be uh, looking towards the earth, sorry, sun. And then what we'll do is we will move to the other end of the earth, and from here we will be looking at the sun. Now since we are moving on the earth, we already know the distance that we have traveled, this small distance b. We will come to know this angle theta between these two lines. Okay, now when you know these two things, what you can do is you can calculate it जैसे हम लोग ने इसमें calculate किया था. One important thing to remember is कि यहाँ पे ये जो b है, the diameter of earth is very less compared to this distance from the sun to the earth. Okay, so again by using that formula, this distance is nothing but this uh, distance from earth to sun is nothing but b by this angle theta. Okay, so this is the formula that we have. I hope you have understood. Let us go ahead. What about measurement of distance to other stars? तो sun तो हमने measure कर लिया, but other stars are very far away from the sun, and from the Milky Way, not Milky Way, from our solar system. So the next closest star, it is at a distance of 4.29 light years. So there will be confusion ki what is light year. So within a year, what is the distance traveled by light is called as light years. Okay, so these are the units which are given. There is one astronomical unit, one light year, one parsec. We'll talk about these three. Okay, so one light year is nothing but distance traveled by light in 1 year. That is what we already talked about. Astronomical unit is the mean distance between earth and sun, the centers of earth and sun. Okay, so earth is going around the sun, it is not going exactly in a circular orbit. So the distance changes between earth and sun, and the mean distance between them is nothing but astronomical unit. One arsec is the distance where uh, one AU subtends an angle of 1 second of arc. Let me show you all this with an example. Okay, so for 1 parsec, sorry. So what we have is this is sun, and earth is going around the sun. Okay, Now from sun to earth, this angle, okay, this angle, if that angle is 1 second, if that angle is 1 second, then uh, then this distance is called as 1 parsec. Okay, so this is what we have as 1 parsec. Now this is the method used to calculate the distance between earth and other stars which are very far away. Similar to while finding the distance to sun, the distance between our two eyes were not adequate. What we did was we moved from one end of the earth to the other end of the earth, right? So over here, for finding distance of uh, stars which are very far away from us, we use this method. So when earth is on this end, we measure this distance, and when earth is again at this end of the sun, extreme end, we measure this distance. Okay, so this angle is known, this we already know. So if one side is 1 Armstrong unit, the total side is 2 Armstrong unit. Okay, and with this angle we can calculate again the distance. So that distance will be nothing but the uh, 2 Armstrong unit by theta, right? So you can calculate it with this formula. Yeah, and this r is nothing but for that 1 parsec. Calculation is for that 1 parsec. Size of the planet, this is interesting. So for planet which is near to us, let us say Mars, Venus, and what, so what you do is you just point telescope to one end of the planet, okay, and then you point it to the other end of the planet. ठीक है, so what you got is you got the angle by this, क्योंकि टेलीस्कोप एक ही जगह पे, यहाँ पे ध्यान रखना कि टेलीस्कोप एक ही जगह पे. नाउ विद द पैरेलैक्स मेथड हमने ये डिस्टेंस ऑलरेडी फाइंड किया हुआ, ठीक है, विद द पैरेलैक्स मेथड हमने ये डिस्टेंस ऑलरेडी फाइंड किया हुआ है. सो वी कैन कैलकुलेट दिस साइज ऑफ द प्लैनेट, वी कैन कैलकुलेट साइज ऑफ द प्लैनेट बाय यूजिंग दिस फॉर्मूला, और फॉर्मूला आ जाएगा d इज इक्वल टू d is equal to capital D alpha. This is nothing but is equal to r theta from circles. S is nothing but arc length, r is nothing but radius, and theta is the angle. So in our case, this is nothing but the arc. So ये circular, this is not actually circular, but it is linear. So we are taking formula related to that. Alpha is the angle which is made, and d is the distance. So this distance is nothing but radius. I hope it is clear to all. Next, measurement of very small distance. So parallax method is definitely not required. We have meter scales for measuring small distances. Even we have vernier caliper and screw gauge. They give you very precise measurement up to 3 to 4 decimals. But let us say we got very small particle like molecules, atoms, protons, उसको कैसे measure करें? So उसके लिए what we have is we use electron microscope to measure the size of atoms, right? So with this we'll stop here and see you all in the next session.